Hello, everybody. What we're going to be doing today is lesson 5.4H. We're going to skip the warm-up because the answer key is technically already there, and that kind of makes it no fun. So what we're going to do is we're going to do this lesson. It's relatively short. And then what I'm going to give you guys is just a quick review of lesson 5.1 over 5.4. It's going to be the activity you're doing today in class. And then once you finish with that, you guys are more than welcome to start your homework, okay? So go ahead and have your notes out. Take notes as if I was right there in front of you. And this one shouldn't take too long. It's a relatively quick lesson. So here we go. Andrew walked around the water park taking photos of his family with a phone. Later, he discovered his phone was missing, so that others could help him look for his lost phone. He drew a picture to recreate his footsteps, showing where he walked. So basically, here's the entrance. He walked around, took pictures over here by the benches, over here by the slides, went over here by the canopies, back over here by the parking lot, and then down here, there's a little jungle gym thing over here. Okay, so it says, if we wanted to determine Andrew's location in the park with respect to time, would the location be a function of time? So would location, oops, let me go ahead and fix that really quickly. Go. Would location be a function of time? Well, let's go ahead and look at this. Remember, the definition is for every input, there needs to be one and only one output. So right here, as time goes by, is there only one output? So, and there's actually a wrong answer right here. So this is actually not a function, and it's because of one and only one point, and it's right here. So at this given point, that will occur at two different times. So let's say, it's the very beginning, so after 1 minute, and he did all this walk, and let's say after another 10 minutes, it would be the same location. Therefore, after every input, you have two different inputs, you had the same output. Therefore, it is not a function. So it's not a, so I'll go ahead and type this just so we can, it's a little easier to read with my handwriting. So this is not a function because at two different times, which is your input, you had the same location, which is your output. That's what makes it not a function. Okay. So now it says, we're going to look at several different situations here. It says, sketch a graph of total distance Andrew walked if he's walking at a constant rate the entire time, following the path of arrows. So all it wants to know is total distance, is total distance. Not his location relative anything, but just his total difference. Oops, and I already did this wrong. So total distance should be on my y-axis. And over here, it's time. So here we go. And we can just go up by like 1 minute every other. It's not asking for anything specific. Well, up to 3, 4, 5, 6, 7, 8, 9. We'll go up to 10. And then, how far is he traveling? Is he traveling feet, meters, so on and so forth? We'll go meters. And, we can just go up by 5. So 10, 20, 30, 40, 50, so on and so forth. And if he's traveling at a constant rate, and we're just talking about distance, it would look something like this. So after 1 minute, maybe he traveled, he's taking pictures, so maybe he's going a little slow, 10 meters a minute, okay? There we go, 10 meters a minute. So it looks something like this. And your x and y axes can differ as well. Now what we're going to do is we're going to sketch a graph of Andrew's distance from the entrance, okay, so there's his entrance, a starting point, as a function of time, following the path of arrows as he marked in the picture above. Label our x and y axes. Okay, so here we go. Sketch the Andrew's graph of distance from the entrance. Okay, so here we go. Same thing. Here is time. And this is distance again, but instead of total distance, it's distance from entrance. So he's doing one of three things. He's getting closer to the entrance, getting further away from the entrance, or he's staying equal distance away from the entrance. So let's go ahead now and look at this. As time goes by, he's getting further away. He's moving like straight away from the entrance, so he's going pretty quick. That would represent like this value right here. And then I need to figure out, is he going further away at a faster rate or a slower rate? Well, I would say it's basically a slower rate. So I'm going to represent that with a light blue right here. So his distance is still going away. It's just going away at a slower rate, and he's going pretty far. So we'll go like that. So that represents basically this spot right here, okay? And I guess technically this should be two colors right here. So then basically then he went even further, and it was a little faster rate right there. So that's the second blue spot. Then if you notice, he's coming a lot closer. Made a nice quick turn going closer to the entrance. So that would be about this. And now he's going really close. He's going really close to the entrance again. So here we go. He's getting closer. And then closer again. And he's getting pretty darn close to the entrance. But then what he does is then he goes back away from the entrance. Something like this. That was just a rough sketch. It would be something, as long as you have a general picture, maybe you thought that he moved faster here, so on and so forth. But generally, it should look something like this. And it's always important, you got to figure out what is your y variable, what is your y-axis, dependent variable, and you just got to make sure distance from the entrance. Okay, how would the graph of each situation change if Andrew stopped at the slide for a long period of time? Okay, so we got situation A and B. So here is the slide. So let's say that was, looks about his halfway point. 1, 2, 3, 1, 2, 3. So at his halfway point, and I said he traveled for about 7-ish minutes or so. So at the halfway point, at 3 minutes and 30 seconds, he took a break. So let's go ahead then and look at this. So this is total distance. Oops, once again, total distance. And right here, it would have been time. And so basically what this graph would look like is he would still continue to travel at a constant rate, but about halfway through, he stopped to take a break. So really quickly, his total distance isn't changing, but time obviously continues. Then after that mark, when he's done taking the break, he would then be traveling at the same exact rate as before. Okay? All right. Now over here, at the halfway point we said was located right here. I'm going to go ahead and take a screenshot of this graph just so we can use it as a, oops. I'm going to take a screenshot of this graph so we can use it as a quick reference. All right, so over here. And we're just going to cover that up for 1 second just so we can, yeah, we're going to put it right below there. All right, so just as a quick reference, we can look at this graph. So it's the same thing occurred as last time. So over here, so he went pretty far away from it, and then he went at a slower pace, and then he went at a little faster pace. Then he just took a break. Now remember, this represents the total distance away. Well, distance is, if he's resting, if he's just sitting for a second, the distance isn't going to change. So then his graph would look like this. So right here, guys, That's about the halfway point. That's where the rest would have taken place. So then from there, he would go in closer and closer to the entrance, and then he went back away, okay? So, and I forgot to do the X and Y axis, so let's go and do that as well. So would this change whether or not, how would it change the direction, intercept the function inside the period, show changes on the graph. Okay, we did that. And let's not forget this. This would be time. And this is distance from entrance. Okay, would it change whether it's a function or not? And in both these cases, no. It would not. Because it's not saying, with this situation in particular, it's not saying that he's in two places at the same exact time. Okay? So, how did you decide on the key features of the graph? Discuss these decisions below. Include your discussions of intervals, of increasing, interval notation, domain, range, maximum, minimums, so on and so forth. Now, what I want you guys to do, so everyone's going to have their own graph, and then what we're going to do is I'm going to show you the general rules. So I want you to label the X and Y axes on all these. I want you to put these in intervals so you can add them, and then you can compare it to mine, okay? So go ahead and pause this video, add the intervals, do all of number 5. Okay, so right now, guys, you should have done all the intervals, and since you guys all have different graphs, I'm only going to label the general term. So really quickly, your domain will have to start at 0 and go to however far you said. Mine was 7 minutes, so it was 0 to 7 minutes. If you did yours in seconds, it might be a lot different, okay? I also said meters was my unit, so I said like 0 to 70 meters, I believe, for range. So range for me was 0 to 70. All right. That was the first one. And on this graph, we can also just say, you know, I didn't really do the specifics over here, but I could say, you know, he traveled like 35 meters was his furthest point. Okay, and this is just, like I said, a really rough sketch of it. So let's go ahead now and look at this. So that would have been domain and range. And here on this graph, we would say it is increasing from here to here, here to here. I can go ahead and highlight that so we can see exactly what I'm talking about. So this is where it would be increasing, and this is where it would be increasing. On yours, guys, remember you'll have your intervals clearly labeled, and you can say exactly where your graph is increasing. Okay, so I really want that in interval notation. Remember, you need parentheses with interval notation. And then over here as well, it's increasing here, 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 and here. Once again, you would need intervals there. All right, here I am decreasing, so I would say that for the interval. Let's see, next one, I would say if it's constant where it's not changing at all. So in light blue, that would be like right here, and obviously right here. That's the constant, okay? All right, so we talked about increasing intervals, decreasing interval, domain, range, maximum, and minimum. Well, on both of these guys, the minimum is going to be 0. And the maximum is just our points that we're going to put. So on this one, on the domain, or excuse me, on my first graph, I said the maximum was 70. And on this one, we just really quickly put this value right here. On here, we would say on graph 2, or situation B, I would say, the maximum was 35, with the minimum also being 0. Now, remember, guys, this is graph A. This is graph B. You guys had clear intervals, so make sure you have them all clearly labeled. And believe it or not, that is the lesson, okay? If you have any questions with this lesson, please feel free to email me. Now, to make sure you guys aren't bored for the rest of the period, this is what we're going to be doing. We have an activity of, it's 5.1 through 5.4, and we're not having a quiz for this module, but it's called quiz review. I also provided you with a key, so make sure you check your answers on the key. Once you're all done with 5.1 through 5.4, what I would like you to do is then begin your homework, which is just home or RSG 5.5. And that is it, guys. I hope you have a fantastic weekend, and I will see you guys on Tuesday. As a quick reminder, you guys have a test next Friday, so a week from today, day before break. All right, guys, see you later.